My name is Graham Sakaki. I'm the research coordinator for the Mount Arrowsmith Biosphere Region Research Institute at Vancouver Island University. We're up here in early November on Mount Arrowsmith. We're installing a weather station and snow pillow. We're super excited to finally have this project up and running. Freshwater has been a growing concern in the region, and one of the things that the data will be able to do is inform how much water will be available for the populations below in the summer months.
It's a unique opportunity for different governments and the university to work together to collect data. And normally, when these sites go in, they go in just as a snow pillow with the Ministry of Environment snow program. So they collect snow water equivalent, which is basically the weight of the snow on the ground. They collect snow depth. They collect total precipitation, which is rain and snow, and air temperature. So those 4 parameters are the ones that are most important to their program. From a research perspective, we like to collect a little bit more. So we've installed a wind speed sensor, we've installed a net radiometer, and we've installed soil temperature, moisture, and also relative humidity. So all those different observations are really important if we want to develop models to actually build a snowpack and melt them. Because we had the 4 groups come together with different funding, we were able to do more of this. So VIU was able to provide a bunch of the more expensive equipment, like the net radiometer. And we've used the infrastructure that the snow program has to build upon it. The Ministry of Forest, which I'm part of as well, we have a research program, so I put these towers up as well throughout the province, generally in areas where the snow program doesn't. So we've started to work together and sort of leverage resources and leverage money. It's too bad we didn't have 30 or 40 years of this data, but you got to start it sometime. So we're putting it in now, and this will hopefully run in perpetuity when we're retired and dead. This will hopefully keep going. And these types of long data records are really, really important for looking at trends and actually describing climate. You know, the next couple of years we'll be describing weather, but as we get more and more data, we'll start building a climate data set that we can say that, yeah, for the next 30 years it has been warming, or we've had some El Niños come in, or a Pacific decadal oscillation that's turned into a cooling trend. Having that data will allow us to actually quantify that. We're monitoring so much at this site, we can use the data to refine different types of models and make them better. So we have a bunch of models that we use to melt snowpack. And the sophistication of that model depends on the data to drive it. And when we have a lot of data to drive it, we can use a model that's better, and we can also improve how that model works. So I use some physically based models that need more data to run them. And as we get more data, we'll actually be able to test how these models work elsewhere and improve them. So there's so much we can do, and it's quite exciting.